Imagine asking a robot to drive from point A to point B. It could make sharp turns or follow one smooth path. That's what Pedro Pathing helps FTC teams do. Pedro Pathing is an autonomous path following library for FTC robots. One of its biggest advantages is this web based visualizer where you design paths just by dragging control points. But how does dragging a few points create such a smooth curve? The answer is a Bezier curve. It sounds complicated, but it's built from one simple idea: linear interpolation. Linear interpolation just means finding a point somewhere between two other points. Imagine a point P sliding from point A to point B. At the halfway mark, it sits right between the two. Closer to the start, it's near A. Closer to the end, it's approaching B. That position is controlled by a parameter t from 0 to 1. When t is at 0, we are at A. When t is 1, we've reached B. Every value in between gives a point along the line. A and B are actually coordinates. Say A is at 2, 1 and B is at 8, 7. This is a weighted blend of A and B. At t equals 0.5, both weights are equal, so P lands exactly on the midpoint, that is 5, 4. Pedro repeats the same idea layered on itself to build an entire Bezier curve. We start with 3 points. A is where the path begins, C is where it ends, and B is the control point. The robot never actually drives through P. It acts like a magnet, pulling the curve towards itself. Using the same parameter t, point D slides along A to B, and at the same time, point E slides along B to C. Now connect D and E and interpolate one more time along that segment. This gives us the point P. As t moves from 0 to 1, P leaves behind a trail. That green trail is the Bezier curve, 3 interpolations nested inside each other. This process is called de Castle-Jer's algorithm. This also explains something important. The curve isn't stored as individual points. It's generated from A, B, and C mathematically. So moving even one control point changes the equation, which reshapes the entire curve, not just the part nearby. That's exactly what's happening in Pedro's visualizer. You drag a control point, and Pedro recalculates the curve underneath in real time. No equations, no manual coordinates. You are directly shaping the math itself. Once you're happy with the path, the visualizer generates a code for you, ready to drop into your autonomous program. That's what makes it so powerful. Instead of calculating paths by hand, you can focus on designing and testing better autonomous routines.